A highway safety institution conducts experiments in which cars are crashed into a fixed barrier at 40 miles per hour. In the institute's 40 mile per hour offset test, 40% of the total width of each vehicle strikes a barrier on the driver's side. The barrier's deformable face is made of aluminum honeycomb, which makes the forces in the test similar to those involved in a frontal offset crash between two vehicles of the same weight, each going just less than 40 miles per hour. You are in the market to buy a family car and want to know if the mean head injury resulting from the offset crash is the same for large family cars, passenger vans, and mid-size utility vehicles. Okay, the data in the accompanying table were collected. So let's open the table. Let's bring it into StatCrunch. And then we're going to do some ANOVA. Right, what we're interested in is whether the mean value for the three samples is the same, right? If let me say a different way, we want to see if this data supports the hypothesis that, well, all three of these types of cars have the same mean collision value, whatever it is, or whether one of them is different. And that's what we're looking for. The null hypothesis that the mean for cars equals the mean for vans equals the mean for SUVs, and the alternative is that at least one of the means is different. So if normal probability plot indicate that the sample points come from normal populations, are the requirements to use ANOVA satisfied? Yeah. Well, as long as we've got random samples and it says that this institute study, yeah, I mean, I think this is fine. But let's just check. Let's go back to StatCrunch and let's just do a little stat. Let's calculate summary stats for all of this data. Here's what I want to compare. I'm going to compare their standard deviations. Okay, I'm going to compare them, and let's see. Standard deviations: 197, 188, 128. We want to ask, is there sufficient kind of evidence here to suggest that one of the populations has a vastly different variance? Well, I don't know. I think that we can probably, I mean, you can see that the mid-sized utility vehicles have a smaller standard deviation than large family cars. But I think that that's fine. Certainly, look at choice C. The largest sample standard deviation is more than twice the smallest. No, that's not true. The samples are independent. The populations, yeah. Let's see if they're normally distributed. We can do that by doing a normality test on our data. Let's just throw all this stuff in and just run a normality test and see what we get. Normality test is a very easy way to test if your data is normally distributed. So you've got your sample, and the hypothesis test is null hypothesis. The data is normally distributed. Alternative, it's not. So if your p-value is small, you would reject the null hypothesis. All of these p-values are bigger than, say, 0.05. So there's no reason to say any one of these is not normal. So we're going to say they're all normal. So yeah, everything's there. All the requirements are there for doing a ANOVA. So let's do the ANOVA. Let's do stat ANOVA, a one-way ANOVA. And let's get our data, click compute, and we have our ANOVA table, which has an F statistic in it to 3 decimal places, 0.391. All right. And the p-value here is 0.68. I'm taking what, 3 decimal places? Oh, 4. 1.8. The p-value is big. That's very big. I don't want to reject the null hypothesis. So there is insufficient evidence to reject the null hypothesis. Thus, we conclude, what? Cannot conclude that the means are different. Certainly not at an alpha level of 0.01. 0.68 is a very big p-value. Box plot for the 3 vehicles. Okay, now let's do our box plot. Let's close this stuff, or let's move it to the side. Stat, or no, it's graph. Graph, box plots. Let's do side-by-side box plots. And make them horizontal. And click compute. We've got boop-a-doop-a-doo. All right. We've got large family cars, passenger vans, and SUVs. So we should have SUV, van, cars. And it looks like it matches this. I think so. Yeah, for sure. Great. Well, anyway, that's how we do ANOVA in StatCrunch. I hope you do well on the assignment. And let me know if there's anything you need. All right. Bye.